If you have a firm handle on application problems with equations, solving real-world problems using inequalities will be a piece of cake. When you're working with application problems, it's always best to define the variable. In this case, the variable P stands for profit. And it's with inequalities, you need to figure out what symbol you are using. Greater than, less than, greater than or equal to, less than or equal to, was at least. So if it is at least 3,500, that means it has to be 3,500 or more. So I'm going to have my variable, profit, needs to be at least greater than or equal to 3,500. So it's at least 3,500, that is true, and it can be anything greater than that. If you're wondering how to check it, put in something that makes sense. So 3,500, is that greater than or equal to 3,500? Yes. It is at least 3,500. Or 4,000. Is 4,000 at least 3,500? Yes. So we know we have our symbol going in the correct direction. Alright, here's one that's a little bit more difficult. We know that applications for inequalities are almost identical to equations except for the inequality symbol. So we're going to have an inequality symbol instead of an equation. This is very similar to a problem you did with equations though. So let's look at the problem. Water park charges $15 for admission. So up front we're paying $15. So this is our y-intercept. And it also charges 15 cents per game. This per is a clue word. So this is going to be our slope because we're going up 15 cents for every game we play. That leads us to our let statement. Let x be the number of games. Don't forget to write that let statement just like you did with equations. Alright, so now we only have $23 to spend. So I'm going to think about this in words first. I know that the amount you spend needs to be less than, or it could be exactly what you have, the amount you have. If you think about it in words, the rest of this is pretty easy because we know we're getting charged $15 up front plus 0.15 or 15 cents for every game we play, which is our x, and that has to be less than what we have, but it could be exactly what we have, which is $23. And then it's a matter of solving the inequality. So 0.15x is less than or equal to 8 after we took 15 away from both sides, and we have to divide by 0.15. 8 divided by 0.15 is 53.3 repeating. But what does that mean? It means that our number of games has to be less than or equal to, so it could be anything that is less than or equal to 53.3. Since we can't play a third of a game, the maximum number of games that we can play is 53 games. But I want to make a very important point here. Sometimes it asks, what is the number of possible games? So all possible games, or all possible solutions. In this case, since the solution is any number that is less than or equal to 53, if the question was asking what is the all of the possible solutions, we could play any number less than or equal to 53, and I apologize for my handwriting. So if the question was asking for all possible solutions, you could play any number of games less than or equal to 53. Alright, one last example is one of these that you're just trying to find a number. So 3 times a number, we know what that looks like. So x, let x be our number. Don't forget your let statement. So 3 times a number we know looks like this. Is more than or equal, it doesn't say or equal to, so it's just going to be is more than 33. So we'll solve this simple inequality. So x has to be any number that is more than 11. So what are the possible values of this number? This is what I was talking about with the last. It's not saying what is the maximum number, what is the least number, all possible values. So x is any number greater than 11. And we could show this on a number line as well. So 9, 10. So set up your number line and number it so we can see what the hash marks stand for. It's greater than, it doesn't include 11 though, so open circle, and it goes this way. And that is a short tutorial on application problems.